Today we're still with function operations, but now we're going to look at composite functions, which that's where we combine two functions. So for instance, f of g equals f of g of x. So let's take a look at some example problems. So f of x equals x minus 2, and g of x equals x squared. So we have g of f, so that means we want to take g and then find f of x. So when we do that, f of x we know is x minus 2. And so instead we take our g of x and replace our x minus 2 with the x. So we end up with x minus 2 squared. So let's take a look at our second example. F of g of negative 5. So we take f of g of negative 5. So we need to find what happens when we plug in a negative 5 for our g. So we have f of, and if we plug it in, we end up with negative 5 squared. Negative 5 squared is 25. So now we have to find f of 25. So we take our function of f, plug in 25, minus 2. So we end up with 23. So let's look at the last couple of examples. We'll let g of x equal 2x and h of x equal x squared plus 4. So what happens when we want to find h of g and then h of g of 2? So this is going to equal, take our g, so it's going to be h of our g, which is 2x. So for our h, in place of our x, we're replacing 2x, so we have 2x squared plus 4, which that is 4x squared plus 4. So our second one, so we take h of g of 2, so we plug in 2 in for our g, so we have 2 times 2, and 2 times 2 is 4, so then h of 4 becomes 4 squared plus 4. And 16 plus 4, we get an answer of 20. So last one, so we have g of h. So gh is our x squared plus 4. So instead of our x and our g, we're replacing it with x squared plus 4. Distribute. So we have 2x squared plus 8. So our last one. So we take h of negative 1. So in for our h, we plug in a negative 1 squared plus 4. Negative 1 squared is a positive 1 plus 4. So we end up with 5. Then we plug in a 5 in for our g. So we have 2 times 5. So our solution is 10.